In this video, we are going to discuss about Wein bridge oscillator. This is also called as lead lag oscillator. So the circuit consists of two RC stage of two RC coupled amplifier. So this one will produce a 180 degree phase shift, and this one will produce a 190 degree phase shift. So total it produces 360 degree phase shift or 0 degree phase shift. So this here a balanced bridge circuit. So this is called as balanced bridge circuit. So here we are having R and C and C and R. So this R and C is nothing but a low pass filter, and C and R is called as high pass filter. So this is also called as lead, and this is called as lag. So that is why it is called as lead lag oscillator, which will not produce any phase shift. So this will produce a 0 degree phase shift. Okay. So this is connected at the feedback. You can see the output is connected to the input of this balanced bridge network, and this output is connected to the input of the amplifier. So generally in oscillator, amplifier stages which will introduce a 180 degree phase shift, and feedback network will produce another 180 degree phase shift. Totally you have 360 degree phase shift. This is a condition required for oscillator, but in the bridge we are using a non-inverting amplifier which doesn't produce any phase shift, and total phase shift is 0 degree, and the balance bridge network also it is not producing any phase shift. So totally it is producing a 0 degree phase shift. So let me take this R1 and C1 is in series. So I have taken Z1 that is as Z1, and R2 and C2 are in parallel, so I take it as Z2. So this is a amplifier. We have two amplifier which will produce a 0 degree phase shift, and the output is connected to the input of the RC and R2 C2. So we know that from the voltage divider rule, VF is your if you want to find the value of VF with respect to VINOD, you have to apply the voltage divider rule. So I can apply voltage divider rule. VF is equal to V0 into Z2 divided by VF is equal to V0 into Z2 divided by Z2 plus Z1, right? By using the voltage divider rule. So what is VF by V0? VF by V0 is beta. So that is equal to Z2 by Z2 plus Z1. We know that Z2 is R2 in parallel with C2, and Z1 is R1 in series with C1. So I can write this R2 in parallel with 1 by C2 is R by SC2 divided by R plus 1 by SC2. So here I can take I can write R1 R2 is equal to R, and C1 C2 is equal to C. So if we substitute this this term Z1 term in this equation and Z2 term in this equation, and you can multiply this SC here, and 1 plus RSC here. So 1 plus SCR and 1 plus SCR get cancelled out. So you will get this SC will go to the numerator. So you will get RSC divided by RSC plus 1 plus by applying a plus b the whole square formula, 1 plus 2 rsc plus r square s square c square. So you substitute s is equal to j omega here. So if I substitute s is equal to j omega, so you will get this term. And next you have to multiply j and j to the numerator and the denominator. So if I multiply, you will get the j square is nothing but minus 1. So what is beta? Beta is equal to minus omega rc divided by minus omega rc plus j minus 2 rc omega minus j omega square r square c square. So we know that by equating the imaginary term you will get the frequency, right? So equate the denominator term. What are the terms? This and this one. So if we solve 1 minus, right, this is your imaginary term, 1 minus omega square r square c square, that is equal to 0. So you will get omega square is equal to 1 divided by r square c square. So you can take the root. By taking the root, omega is equal to 1 divided by rc. So f is equal to 1 divided by 2 pi rc. So it should be in hertz, right? Sorry. So next I need to find the value of gain. In order to find the gain, so equating the real term. So in this equation, so if this get to 0, you will get beta is equal to minus omega rc divided by minus rc minus 2 rc. So, okay, so this is nothing but so if I substitute minus omega rc divided by, this is minus 3 omega rc plus j minus j omega square r square c square. So this term already goes to 0. So this omega rc and get cancelled out. So we'll get beta is equal to 1 by 3. So we know that modulus of a beta is equal to 1. So a is equal to 1 by beta. So you substitute instead of beta, you substitute 1 by 3. So you will get a is equal to 3. So the gain of the oscillation of the Wein bridge oscillation using the BJT amplifier should be at least equal to 3 for the oscillation to occur. Okay. Suppose if they are given the value of r is equal to 100k and frequency of oscillation is 10k, and they want to find the value of c. So what is the formula? F is equal to 1 divided by 2 pi rc. Okay, so I need to find the value of c, that is equal to 1 divided by 2 pi. F is 10 kilohertz. 10 is 10 power 3. 10 power kilo means this is 100 into 10 power 3. So on solving these two values, I will get 159 picofarad. Pico means 10 power minus 12. So this is the value of C. Thank you.